Hi guys, welcome back to my channel. Today we're going to look at some questions related to exponential functions. And specifically we're going to look at using some graphing technology. So I'm going to use Desmos. If you've got a graphics calculator at home, please use that. If not, Desmos is a pretty good alternative. And we're going to sketch the following graphs on one set of axes. So I've got three equations there. Y is equal to 3 to the power of x, y is equal to 3 to the power of x plus 2, plus 5, and then 3 to the power of x minus 3. So I'm going to draw those graphs and then I'll come back. Okay, so I've gone ahead and I've sketched these four graphs now. So what remains the same in all of these graphs? Literally, they are the exact same graph. The only difference is that they've been translated up and down. And I'm sure that you guys probably picked that because we had a look at some different transformations in our last video. So this addition of the constant on the end is going to shift our graph up or down. What has changed? Well, let's talk about a few features of each of these graphs. Now, with this line here, the reason that we have this line here is because if I have a really, really small number, a small number raised to a higher power is not really going to get any bigger. And so we really see this very flat line for a very, very long time. And then as soon as we hit positive values of x, that's when it starts to go up pretty steep. And so this line here, this line looks like it's going to almost touch one of the axes. So it almost looks like it's going to touch 0 for this red line here, but it never actually quite touches 0. So when it's reaching for a point but never actually touches it, that's called the asymptote. So these four lines here, these are all our four asymptotes. So those have actually changed. So for our red line, we've got 3 to the power of x. So our asymptote is going to be equal to 0 for our first line. For our second line, y is equal to 3 to the power of x plus 2. Our asymptote is going to be at this point here at 2. Oh, sorry, I should write the full function. This is a horizontal line, and so with horizontal lines, it's going to be y is equal to 0. If it was a vertical asymptote, it would be x is equal to 0. So we've got y is equal to 2 for our second asymptote. For our third asymptote, you can probably guess straight away from the formula what the third asymptote is going to be, and our third asymptote is going to be y is equal to 5. And then our last asymptote, this black line here, this is going to be y is equal to negative 3. So those are our four asymptotes, so they have changed. What else has changed? Well, if we have a look at our x and our y-intercepts, let's look at our y-intercept first. What's changed about our y-intercept? Well, we can see here that this y-intercept has been shifted down, and this is actually going through at, each of these squares are 2, so this is going through at negative 2. So our y-intercept is going to be, for our black line, at 0, negative 2. For our red line, so this was our original function, we can see that that's halfway through, so that's going to be at 0 and 1. For this next line here, this green line, this was our second equation, so y is equal to 3x plus 2. We can see that's been shifted up 1, 2, 3, so that's gone up 0, 3. So you can literally see this was our original y-intercept, and each of these have just been shifted up by the amount, the same as what their constant value is listed on the end there. So if this original asymptote, this original y-intercept was going through at 1, 0, and this has gone up 5, this must be going through at 0, 6. So let's check that. So if we go up to this purple line now, it should be 2, 4, 6, and it does. It goes through at 0, 6. Okay, the last thing then that we need to talk about is the x-intercepts. Okay, so the x-intercept is when it is crossing over in the horizontal axis. And so for some functions we've seen where we've had 2 or more x-intercepts, but I hope that you can appreciate for these lines, these are definitely functions, and these only have one x-intercept. So for this one, this is actually not even crossing the x-intercept at all because we've completely shifted it upwards. Same thing with this green line here. So that green line was going to be equal to our second line. Now our red line, it's almost looking like it's touching, but it never quite does. That's the thing with these asymptotes. They never dip below that particular point. So the only one really that's got an x-intercept in this case is going to be this one here. So it definitely has one intercept maximum. Sorry, I said one definitely has one before. I should have said it definitely has one maximum, possibly 0, definitely no more than 1, whereas a parabola can have 2, cubic functions can have maximum of 3. So this one here, this is going to go through at this point. So I'll just go and determine what that point was. So this is at the point 0 and 1. Oh, sorry. Let me fix that. This is at the point 1 and 0, of course, because that's our x-intercept. So when y is equal to 0. That was a little bit silly. Okay, so for the graph of 3x plus 10, write down the y-intercept. Okay, well, we saw before, so when we had this base function, the y-intercept was at 0, 1, and since we added 2 to the rest of these, and then 5 to this one, and then -3 to this one, these y-intercepts all jumped up that amount as well. And so we can probably just add 10 to this, and this is going to go through at 0 and 11. So let's just double check that by sketching the graph. So this fifth line up here, this is our graph of y is equal to 3x plus 10, and it does indeed go through 0, 11. And the last one, the equation of the horizontal asymptote. Now, if it's a horizontal asymptote, it's going to be y is equal to something. And we can see from those previous values again that really this constant at the end here ended up becoming our horizontal asymptote as well as shifting the graph up or down. How interesting. So for this one, we can write that the asymptote is going to be found at y is equal to 10. So if we just go back to our graph, so this is our asymptote here, and we can see that this is going to approach 10. It's never actually going to reach 10. So that's just a quick sketch. And again, most of these questions in the textbook are all relating to using a graphics calculator or using some sort of graphing tool. So this is a very similar sort of question here now. So given the graph of y is equal to 4 to the power of x, sketch on the same axis of graphs the graphs of y is equal to 4 to the power of x, take 3. So having a look at all those questions that we've just done, all we need to do then is we need to draw this exact same graph, but it just needs to be shifted down by 3 units. That's a little bit tricky for me to do, so I'm not going to do it by hand. And this last one for question 9, this is now flipped. And remember, when we flipped, all these values of x that were positive are now negative. So this is going to flip across, and this is going to come this way. So let's attempt to draw this. Oh, that is beautiful. This is why I teach maths and not art. Oh my gosh. Okay, so a couple more transformations here. So if you're given y is equal to 2 to the power of x, sketch the following graphs on the same set of axes. Okay, so we've got this value here, this negative x, so that's automatically going to flip my graph. And then it's got this value of plus 2, so it's going to shift that graph up 2 compared to the original value of 2 to the power of x. Excuse my beautiful drawings there. Okay, the next one, we've got -2. Now remember when we spoke about this, this was, the brackets were like wrapping around this 2 to the power of x. So it's the exact same now, it's just been flipped across the x-axis instead. So it's been flipped. If this was our original graph here, then it's now been flipped to go this way instead. And then also it's been shifted up 3 units. So this will actually come down something similar to that. Okay, so just a couple of quick rough sketches there for you to get the idea. Let's go through and let's do one last proper official example, and I'll do working out and everything. By considering transformations of the graphs y is equal to 5 to the power of x, sketch the following graphs on the same set of axes. So let's say we didn't have a graphing tool available, but I know very roughly that y to the power of x is going to form some sort of exponential function. So let me just quickly draw. I'll draw that 5 to the power of x in red. So that's going to be my 5 to the power of x function. So let's label some key parts of this graph. So y is equal to 5 to the power of x. We can find our x-intercepts by letting y equal 0. In this case, we're not going to have any x-intercepts, so that won't be necessary. We will, however, have our horizontal asymptote. And remember, that horizontal asymptote was equal to this value for c. And here, this value is going to be 0. So we can just write that the horizontal asymptote is going to be at y is equal to 0. Now let's go ahead and find our y-intercept. So in other words, when x is equal to 0, so y will be equal to 5 to the power of 0, which is 1. So we're going to have this point here, which is going to be at 0, 1. Okay, so now we can do the same thing. for these couple of graphs here. We've got y is equal to negative 5 to the power of x plus 10. So considering our transformations, we know that that's going to be flipped in this direction, and then it's going to be shifted up 10. So let's go ahead and let's work out some of these points. Well, this horizontal asymptote was equal to this constant at the end here. So we can say that the horizontal asymptote is going to be at y is equal to 10. And we can say if we wanted to find the y-intercept, this is going to be when x is equal to 0, so negative 5 to the power of 0 plus 10. So this is going to be equal to negative 1 plus 10. So this is going to be found at 9. And again, we saw that in our transformations from before. So this will actually be coming through at this point here. And this one is actually going to have an x-intercept. So we could actually find the point of the x-intercept if we were interested in doing so. So this is at 0 and 9. And this is our horizontal asymptote at y is equal to 10. And lastly, we've got this one here. So let's do a different color. So we've got y is equal to 5 to the power of negative x. So this, remember, is going to flip across in this direction, and then it's been shifted up 10 as well. So this is actually going to come back this way. And again, we can just double check that with our horizontal and vertical asymptotes. Oh, sorry, our horizontal asymptote and our y-intercept. So let's do a horizontal asymptote first. So that always ends up being the value of this constant. So y is equal to 10, and that's what we saw. That makes sense because it's going through that same point there. Then we know that this has been flipped across. So let's see how that impacts the y-intercept. So in other words, when x is equal to 0, so we're going to have y is equal to 5 to the power of, well, negative 0 is still going to be 0 plus 10. So this is going to be at 11. So just the same as it was before. Awesome. Okay, so if I can do that point, I should probably draw it a little bit higher. There we go. So these horizontal asymptotes are going to be at the same spot, but this blue line should just be a little bit higher because that should actually be going through at 0 and 11. Alrighty, so those are just using some transformations. So really recommend using a graphing calculator or Desmos to do that. It's actually pretty fun to play around with this in Desmos, especially if you just set some random parameters like A and you add in a slider, and you can see what each of these graphs is going to do when it has these transformations. Alright, see you in the next video.